Good morning, everybody. My name is Stella Melo, and I work at the Environment and Climate Change Canada, more precisely at the Meteorological Service of Canada. What I want to do today is to have a conversation with you about precipitation. And I want to walk you from the why, looking at the Canadian context, and illustrating with a brief overview of what we are doing at Environment and Climate Change Canada. My intention is to lead us to understand and where we could best use satellite data, the stage that we are, and what could be done in terms of collaboration. So to start, water is a central element for life. Therefore, in the context of building resilient societies, water is a very important parameter. And what redistributes water in the planet is precipitation. So precipitation becomes then a central element if we want to think about, understand, forecast, and manage the water resources. And it is not an easy parameter to deal with. There are lots of uncertainties, mainly on the clouds and precipitation in itself. In this cartoon, I show a little bit of the interlinkages of precipitation and the entire water system. There is lots of science developed around it, and yet it remains a challenge. So in terms of the Canadian context, Environment and Climate Change Canada is the federal department with the mandate to develop and implement environment, water, weather, and climate services, policies, and regulations. It's a challenging thing to say. It is an organizational priority for Environment Canada to provide quality services for Canadians, and precipitation is one of those because it's used by a variety of users internally and externally. You see in the figure on the right side the extension of our precipitation network. It's a beautiful network and vastly populated on the south part of the country. But you see that when we go to more remote areas, we have less coverage. So it is so because if you think about the Canadian context, we have a cold season that can vary from 3 to 9 months. We have a very different regional, the conditions are very different across the country. Therefore, if we think about a ground-based network, it needs to be vastly different. And another aspect to this is that we need to measure a series of complex parameters, which is very complicated from the monitoring perspective. So satellites are the most viable means if we think about global coverage to overcome this kind of difficulties. The challenge that we have is understand what kind of technology best suits and what kind of parameters should we focus attention at. So when you look into precipitation from the requirements perspective, it is also a challenge. You can see that important to these are systems that are at continental scales as much as systems that are very local and occur in very small scales, but can affect an entire population living in a city or living in that context. In Canada, we have what we call the Precipitation Roundtable, which is an initiative that puts together from the science all the way to end user to understand what we need into this context. And this community put together the list that you see on the right side, in terms of what kind of parameters we need to measure. And you see that goes from precipitation amount, snow depth, all the way to the fog. It's very comprehensive. If you think about what kind of activities we're doing, there is lots being done inside Environment Canada. And what I want to show here, it goes all the way from looking into new satellites, which working with the NASA GPM IMERGE, for example, which is pioneering in terms of integration of data from different platforms and different satellites to derive products, all the way to initiatives to concepts that are not in space yet, like the ESA, JAXA, EarthCare, ACCP, NASA investment, like the ESA Weaven concept, and this Canadian Space Agency concept to measure snow on the ground. We call it TSMM. But we also conduct a series of process studies to improve the representation of precipitation in the numerical models. We use airborne and ground-based field campaigns for that. And we also look into analysis and prediction tools that will also feed the hydrological system, the hydrological forecast system. On that, I will mention the Canadian Precipitation Analysis. We call it CAPA. So we are putting lots of work towards integrate precipitation data into the CAPA analysis. This is an area that I will show more, and it's an area that once implemented into the Canadian system could be implemented in other systems as well. The methodology could be exported to other systems as well. So there is room for collaboration there. In terms of the NASA Global Precipitation Measurement Satellite System, I decided to talk a little bit more about that because of this importance. If you see in the cartoon here that has on the left side that has the satellites, a variety of satellites with Earth in the center, and you see several countries work together to come with this initiative. So it's a different concept. It's a concept that you design a satellite and insert it into a system. So it's instead of one satellite will give you all you want to see, it's the satellite will complement the system. Then you have what you want to get in the end. In the right side, you see a photo that will have a data product. In this case, it's a compilation of about 2 months of data, but you can have data into very different time scales. What we're doing in Canada is using this data in the context of the prediction system. What is innovative here is that we need data with a very small latency, within very short time. The initial experiments that we have been doing is showing that a significant improvement in the quality of the CAPA products. On the right-hand side on top, I show you what is the capacity of CAPA in terms of resolution, and that is a regional scale. But we also have a version of CAPA that is in a global scale as well. We are working with the iMerge products into this context, and feedbacks to improve the iMerge products and the GPM iMerge products in itself, and also derive new ways into which this can be incorporated. So there is an area where we could have more collaboration to include not only the CAPA, but other data as well, including other ground-based data sets. So in summary, what are the key messages here? If you think about the Americas, it's a very vast territory that mostly go pole to pole. So there is a great opportunity here to think about precipitation as a significant parameter for weather, climate, water management, and think about how the Americas could work better together in terms of link efforts, so we can give better products and better services in terms of precipitation that can then feed systems that could be used to address basic questions. The moment is a good moment because for the first time, Canada is taking a government-wide approach to guide investments in the context of space-based Earth observation. And in the core of that strategy is the adoption of a collaborative and user-centric holistic integrated approach. So active remote sensing for space is fast maturing, opening new opportunities. We could work on the model that NASA GPM is doing, but we could also expand this to have a larger integration of ground-based products working into this system-wide. So we would be very happy to discuss any collaborative efforts that could come out of this discussion. On that, I thank you very much.